Dear students, today I'll explain to you important characteristics of the Zener diode that it acts as a stabilizer. How? Actually, Zener diode having a supply voltage Vs and a load resistor. I'm connecting the supply voltage to the Zener as well as I'm connecting load resistor to the Zener. Now, the Zener is a stabilizer if upon varying the Vs supply voltage, if the voltage across the Zener, which is V2, if it does not change, then okay, it is a good stabilizer. Secondly, if RL changes, but the voltage across the Zener V2, even then if it remains constant, then again Zener is a good stabilizer. But one thing is noted down, because Vs and RL are the two variables and output voltage is a dependent variable which we note down, two independent supply voltage and the load resistor. So we vary one by one. First of all, we'll vary Vs and we note down what is the voltage across the Zener. But at that time, RL should not change. Okay, this will be our first plot, first step. Mean you go on varying Vs, note down what is the voltage across the Zener, and at that time RL should remain constant, whatever the knob, maybe it is at 1.5, it may be at 500, no problem. Now secondly, the second step is you keep the Vs constant, maybe here 5 volts or 10 volts or 2 volt, no problem. But you go on varying RL now, like first of all knob is at 150, then 300, then 500, and note down what is the voltage across the Zener. Okay, so that is our second step. Mean you go on varying RL, note down what is voltage across the Zener V2, and but V at that time should remain at some fixed value. So this is our second plot. There are two plots, from the plots we see whether our Zener is a good stabilizer or not. Okay, now let me start. So Zener diode as a voltage regulator. Okay, independent variables. What are the independent variables? Number one, the input voltage, mean the supply voltage, which is Vi, or you call it Vs, or you call it V1, no problem. Load resistor is second variable, let me call it RL, and dependent variable is only the output voltage. Dependent is the output voltage. Okay. Now we first step will be a graph between keeping RL constant, graph between Vi and V1 or Vi or Vs and V0. RL should remain constant for this plot. So this is Vi or this is V0. You take the data, go on varying Vi, note down the value of the V0. V1 is the supply voltage, okay? So this voltmeter tells us about Vi. First voltmeter, 10 division equals to 2.5 volts here. And you find what is the least count of this voltmeter. Okay, it is clear. And maximum voltage is 15. 10 divisions is 2.5 and 1 division corresponds to 0.25. Here this is V0 and maximum voltage is 10. Here 10 division is 2 volts. For the output voltmeter, 10 division is 2 volts. And I would write on here the least count of the voltmeter, Vi and V0. Okay. Now about the connections. 1 is connected with 2, means supply voltage is connected. 3 is connected with 4, means RL is connected now. RL is connected in parallel with the channel. Now the circuit is working. Go on varying the input voltage, it is 2.5 first of all, and note down what is the current, whatever it is, like it is 8 divisions or so, okay. In the output side, what is the reading? So input is 2.5, and here 8 divisions, and 1 division corresponds, you know very well what it is. 1 division is of 0.2 volt. So that becomes 1.6 volt. Okay. Now similarly we take the second reading. Now we are increasing Vi. Now it is at 5. Note down what is output voltage. It is 2 volts complete, and 7 I think. 2 volts is complete in the output side. Now then, if input is 7.5, what is the output voltage? Note down. Okay, here. Now there is 7.5 volts. Note down what is the output voltage for 7.5. It is, I think, 7 divisions, 4 volts and 7 division or so. And 1 division, you know, corresponds to what? 0.2. So this is the total voltage. So similarly, you find the other value. Okay. So this is our first step. When we are taking these values, then at that time RL is constant. Okay, RL is not changed. We are not changing RL. Load resistor is constant. Now we are going to the second step. So this is for this first step of maximum voltage, maximum input voltage. It is near about, I think, 15 volt or so. And what about the output voltage? It is around 8 volts in some divisions. 8 volts and I think 3 divisions or 4 divisions. Right. Then we are coming to the second step. Now second step is what? In second step, the input voltage will be constant, means supply voltage will remain constant now, maybe of any value, no problem. You can keep it, at 10 or 7.5 at your choice, no problem. So maybe it is 10 volts, and what you'll do, go on varying the, load resistor from this knob. It is at 100 now. For 100 ohm, what is the output voltage? From one side it is RL in ohm, and here it is the output voltage. Now if it is 100 ohm, okay, for 100 ohm, the output voltage is very near to 4. And for 200 ohm was the reading. Similarly, you find at 400 ohm, okay, and then for the other resistors. Like 400 ohm, it is near about. Now at 750 ohm, what's the value of the output voltage? It is near about 8 volts, near to 8. 750 near to 8. Then at 1.5 K, was output voltage. then 8 volt complete, and I think this is 2 reasons simply. Okay, then similarly you get the other value for other load resistors, what is the output voltage, and for this data input voltage is constant. Now the output voltage is not varying much, not varying, the variation is too slow, very slow, but the resistance variation is too much, going 1.5k to 2k and so on. So this is our second data. Now then your step will be to draw the graphs between. So now the graphs is like this. Now this is a graph. This is a graph between along this side, it is the load resistor. Along this side is output voltage. You note down just after this value of the load resistor, output is not changing. Output across the Zener remain constant even you are increasing the load. Okay, so this is the critical value of RL above which the output becomes constant. This is the property of the Zener, that RL is increasing but output is not increasing. It's a very small increase. Almost it is constant. Very good property. Now second, here it is RL is constant. The graph is between input voltage and the output voltage. First of all, the output voltage is varying, but after some critical value of input voltage, output voltage becomes constant. So when the output becomes constant, this is very important. Output is not changing, input voltage is varying, is going along this side, but the output remain constant. Output remain constant. This is a property of the Zener. That across the Zener across the Zener diode, voltage remain constant. Okay, and it depend upon what is the breakdown voltage of the Zener. So at the breakdown, whatever the breakdown voltage of the Zener, at that voltage and above that voltage, the voltage remain. Output voltage across the Zener remains constant. Okay, this is all. Thank you very much.